Good morning students, welcome to our online video class of chemistry. We have completed our first two chapters. Today we will start new chapter, chapter 3, classification of elements and periodicity in properties. You have already studied about classification of elements in your lower class, is it? And why do we need to classify the elements? In 19th century, only few elements were known. So it is very easy to study about such elements individually. And with the passage of time, many more elements were discovered. So it is very difficult to study about the properties of such elements. Have you ever went to a large library with a large number of books? Suppose you are going to library which contains thousands of books. If you ask for a particular book, the library staff easily locate the book. How it is possible? Because in library, books are arranged in different categories. And the books are arranged on the shelves accordingly. It is very easy to locate. Like that, many scientists try to classify the elements into different groups in order to study about its properties. And one of the early attempts towards the classification of elements was divide the elements into metals and non-metals. This attempt of classification was failed because most of the elements fell into the category of metals. Only few of them are non-metals, and some other metals show both the metallic and non-metallic character. So it failed. Since then, many more attempts were made by many scientists to classify the elements in systematic ways. We are going to study about some important attempts.
You have already learned about modern periodic table and earlier classification of elements. Let's recall about the earlier classification of elements. Law of triads or Daubernier triads. In 1829, a German scientist, John Daubernier, classified certain elements in the group of three called triads. The three elements in a triad had similar chemical properties. According to this law of triads, elements were placed in a group of three, and they were called triads. These were placed in the increasing order of atomic mass, and the atomic mass of the middle element was found to be approximately equal to the arithmetic mean of other two elements. According to law of triads, Daubernier observed that every middle element has atomic mass which is equal to the average of atomic mass of first and last. For example, atomic mass of lithium is 7 and potassium is 39. Average of this equals 7 plus 39, which is equal 46 divided by 2, which is equal 23. The average atomic mass of lithium and potassium, which is equal to the atomic mass of sodium. Like that, the average mass of strontium and barium, which is equal to the average atomic masses of first and last. But this law was failed because this classification could arrange only a limited number of elements. And next law is Newland's law of octaves, and it was proposed by John Newland, an English chemist, in 1864. According to this law, the elements were placed in increasing order of their atomic weights, And it was noted that every eighth element had properties similar to the first element. In other words, he found that the properties of elements were repeated at every eighth element, like the eighth note of an octave in music. In music, we know that sa, ri, ga, ma, pa, da, ni, sa. The first note and the eighth note are identical. Like that, every first element resembles with the eighth element in their properties. And Newland's classification failed badly while dealing with the heavier elements beyond calcium. First law was proposed by Mendeleev. According to Mendeleev periodic law, the properties of the elements are a periodic function of their atomic weight. And Mendeleev arranged elements in the horizontal rows and vertical columns of a table in the order of their increasing atomic weight. And the demerits of Mendeleev periodic table is position of hydrogen. Hydrogen resembles alkali metals because it forms monovalent ion, that is H plus ion, just like sodium ions, lithium ions, etc. As well as it also have the ability to form negative ion, Cl minus ion. It can form H minus ion. Therefore, it could neither be placed with alkali metals group 1 nor with halogen group 7. And position of isotopes. Different isotopes of same elements have different atomic masses. Therefore, each one of them should be given a different position in the periodic table. On the other hand, because they are chemically similar, they had to be given same position. And next is anomalous behavior of elements. And modern classification was proposed by Henry Moseley. In 1913, Henry Moseley is an English physicist, discovered that atomic number is the most fundamental property of an element, not its atomic mass. Atomic number of an element is the number of protons in the nucleus of its atom, and the number of electrons in the neutral atom is also equal to the atomic number. This discovery changed the whole perspective about elements and their properties. And the modern periodic law states that the chemical and physical properties of an element are a periodic function of their atomic numbers. This is the modern periodic table. The periodic table which based on modern periodic law, that is modern periodic table. In this table, elements are arranged according to the increasing order of their atomic number. There are 18 groups. The vertical columns are called groups, and 7 periods. The horizontal rows are periods. And there are 4 blocks: S block, P block, D block and F block. First 2 group elements belongs to S block, and first group elements are called alkali metals, and second group elements are called alkaline earth metals. And the alkali metals includes lithium, sodium, potassium, rubidium, cesium and francium. They are called alkali metals because they form hydroxide on reaction with water, which are strongly alkaline in nature. And the second group elements are called alkaline earth metals because they form oxides and hydroxides. Elements which belongs to group 3 to 13 are D block elements are also called transition elements, and the elements which belongs to 13 to 18 group of the periodic table are called P block elements, also called representative elements, and the F block elements are called lanthanides and actinides, and it is also called inner transition elements. And the 18th group element are called noble gas group. 17th group elements are called halogen family. There are two series of inner transition elements. Each have 14 elements. The elements in which 4f orbitals are progressively filled are called lanthanides. Atomic number 58 to 71. In which 5f orbital are progressively filled are termed as actinides. Atomic number 90 to 103. In next class we will discuss in detail.